Planning and scheduling are often used in the manufacturing sector to describe a common requirement, the development of future plans to satisfy the demand from customers. However, planning and scheduling tools typically have different objectives and very different functional footprints. This set of slides seeks to show the differences and why these might be important to you when selecting the appropriate one for your needs. So what is APS? Yet another acronym for everyone to cope with, but traditionally, and as defined by the APS, the American Production and Inventory Control Society, it is Advanced Planning and Scheduling. APS solutions typically have techniques that deal with the analysis and planning of manufacturing and logistics during short, intermediate, and long-term periods. They typically have inside algorithms that use advanced mathematical techniques or logic. It will use some form of optimization or simulation. It will consider multiple constraints, including materials, as part of the generation of the schedule or plan, and provide decision support to planners, including ATP, available to promise, and CTP, capable to promise, to decide when an order can be delivered based on the current load and the availability of resources. It will offer ways to save and compare alternative schedule outcomes. In a survey carried out by the Aberdeen Group very recently, when companies were asked what were the most important features in an ERP system, APS came out on top. 75% of companies said that APS was extremely important to them. However, only 19% of them had a fully automated system within their ERP or used a third-party tool like Preactor. Most use spreadsheets to carry out the planning process. In order to understand the problem, we should look at the fundamental difference between planning and scheduling. Planning, typically available in an ERP system, is about working out how much we should make based on demand, either real or forecast into the future. Based on the demand, it works out what to make, how much to make, when to make it, and, in the case of multiple plants or multiple resources that can do the same thing, where to make it. Based on this, it will work out the load on resources, though it may do this with infinite capacity, and what materials are needed. Scheduling tools work out how best to make it. It works out the best way to execute the plan. It looks at the best sequence of work on each resource, works in real time, so will only load operations based on when all resources required are available, and generates a work-to list for each resource over the whole period of the schedule horizon. It will get feedback on actual times and help to manage the inevitable changes that may be required due to, for example, late arriving materials, breakdowns of machines, and changes in the priorities of orders. Planning systems typically work in certain silos, periods, or buckets of time. They will load operations into each bucket, which could be a day, a week, or a month at its extreme, but takes no account of the sequence of operations within each bucket. True scheduling systems are not limited in this way. It is bucketless. It will produce the exact time when each batch is due to start on each resource and when it should end, taking into account the attributes of the previous batch, setup time, and run rates. So planning systems with no access to what should be happening at any time during the schedule horizon cannot give you a true mode that can predict what will happen at some point in the future. It cannot give real-time control of resources or individual orders. Planning systems typically sit above ERP, taking orders, stock, and forecast demand, working out what should be made in each bucket of time. We call this MPS, Master Production Schedule. Scheduling systems take information from ERP and carry out the detailed scheduling process, taking into account the sequencing required based on the rules and objectives you give it. The next two animated slides attempt to explain some of the differences between Preactor 400 GMPS, a planning system, and Preactor 400 APS, a scheduling system. In most planning systems, in a make-to-stock environment, there's no relationship between customer orders and the plan. As orders arrive, they consume stock. When a new plan is generated, it must consider the expected future demand for each product, orders that have yet to fulfill, and current stock position. Using the rules defined for each product in terms of stock cover, the planning system then works out how much of each product to make and when. If finite capacity constraints are used, then the when may be delayed. It may not be an option to make early if shelf life is a factor. In a scheduling system, there is a direct relationship between a customer order and the schedule. As each order is added to the schedule, the timing of each operation step takes into account resource availability, including machines, labor, tooling, and materials available. In some cases, the setup or changeover time will vary according to the attributes of the previous batch on a resource. The result is that for each order, the scheduler will predict when it will be completed. This may or may not be the order delivery due date. Another difference between planning and scheduling systems is the time horizon over which they work. There is quite a lot of overlap, but generally, planning systems work days, weeks, and months ahead, while scheduling systems work in much shorter time frames. The reason for this is the level of detail. Is it really important to know that an operation is due to start at 9 a.m. 6 months from now? Inevitably, something will change before then, such as the actual start and finish times of operations or a higher priority order arriving. Let's look a bit closer at demand and capacity planning using Preactor 400 GMPS. Here we see where a planning tool fits with ERP and the whole supply chain. The ERP system is a transactional system receiving sales orders and maybe forecast sales, and then creating purchase orders and manufacturing orders to respond to the demand. The planning system works in parallel with ERP. The capacity-constrained plan is developed in Preactor GMPS and then fed into the ERP system. When a new plan is to be generated, Preactor GMPS starts by importing finished goods, opening stock levels, sales orders, and forecast future demand. This combination produces a non-aggregated demand for each product over the planning horizon. Resource capacity is defined, and in a make-to-stock environment, what the stock control parameters are for each product. Preactor 400 GMPS has an MPS calculation engine that takes into account for each product the future demand and works out how much to make in each period within the planning horizon. Having worked this out, the planner can then choose a range of options to apply that demand on the capacity available. The result of this is displayed in a variety of ways. For example, for each product there is a stock profile which shows the aggregated demand and the MPS result. The graph is interactive. The user can increase or decrease the MPS values and see the impact on stock levels into the future. An alerts table shows where potential problems will occur, such as overstock, understock, product going out of shelf life, and so on. There are also bar charts showing resource capacity usage. Each bar represents a batch of a product assigned to the resource in each period. Again, these are interactive. Batches can be dragged from one period to another and the impact seen on the stock levels. Preactor 400 GMPS is suitable for applications in a make-to-stock, make-to-order, or mixed-mode environment. It also has a bill of materials feature to generate materials required below finished stock. These items can also be included in the MPS calculation and generation of the plan. Multiple plans can be generated and compared to provide a what-if capability, and reports are available to help with this process. There are many benefits of using Preactor 400 GMPS. It provides the planner with an instant view of the impact of changes to the plan brought about by changes in demand or in capacity available. Instant alerts provide warnings of lack of capacity or product that will run out of shelf life. These features enable a better control of production costs and therefore increased profits. Now more about detailed scheduling. As we have said before, sequencing can be important. This simple example shows why. We have 3 machines, A, B, and C. Each machine does one process step. They all work an 8-hour day. All the components we make have the same 3 steps on the same 3 machines. In the example, we have 3 products, X, Y, and Z. The top table shows how long it takes for each operation step for each product. So product X will take 3 days for the first operation, 2 days for the second, and 1 day for the third. The run times for the other 2 products are shown too. The bottom table shows how the schedule would be if we added all the operations for X first, then Y, then Z. It takes 11 days to complete all 3 products. Now let us load it the opposite way around. Z first, then Y, then X. There are fewer gaps, and then all 3 products are completed in 8 days, 3 days less than before. On top of that, if for example we had sequence-dependent setup times, the mathematics becomes more complex. For example, it might take 1 hour to change from product X to Y, but 3 hours to change from Y to X. The influence of sequence-dependent setup times is shown here. We have 3 products again, blue, green, and yellow. The length of each colored bar represents the run time for the batch. This time we only have a single operation step. The black area between the colored bars is the setup time. The number on the bar is the day required for delivery. If we apply some sequencing logic and stick some of the batches together, we can reduce the setup time. The setup time between products of the same type is 0. Depending on how far we look ahead, we can go further and make further improvements, and the total time to complete all the batches is greatly reduced. In effect, we have had a capacity gain. Let us show again why this has been obtained. In a planning system, operations are loaded into a bucket of time for each resource. As each batch is added, so it takes a portion of the capacity, and we have to take into account the setup time between each batch. Here we have added the orders up to the maximum capacity of the resource for this period or bucket of time. Now let's look at the same load in a scheduling system. Here we have preserved the sequence that we loaded each batch and added the setup time between each. The preferred sequence is green, blue, then red, as this will minimize the setup time, and by doing this we have had a capacity gain or increased efficiency. Now it should be said that anyone can create such a schedule given enough time to do it. Some planners use paper or all boards to do it. Others use spreadsheets, Microsoft Project, or Microsoft Access, but these too can become unwieldy, slow, and difficult to maintain. As Mike Tyson, once the king of the world in boxing, once said, "Everyone has a plan until they get hit." That is so true of manufacturing companies. Changes in materials available, changes in resources available, changes in priorities are all punches that a planner must take on a regular basis, and APS tools are fast enough to fight back. Manufacturing companies are increasingly realizing that to become more agile and deal quickly and intelligently with change, they must use an advanced planning and scheduling tool. It enables the planner to see the impact of change across the order book and try different ways of dealing with the problems that may arise out of the change. This is because true APS solutions accurately model time and the process, and so can predict the real impact of change. This allows planners to systematically make faster and smarter decisions. Here we see where a scheduling tool fits with ERP and the whole supply chain. The ERP system is a transactional system, receiving sales orders, possibly forecast sales, and then creating purchase orders and manufacturing orders to respond to the demand. The scheduling system receives these orders, routing, and BOM structures from ERP and generates a production schedule, which is then passed back to ERP. Updates on the real completion times are received from the scheduling system or from ERP, so that when a reschedule takes place, it can take into account the progress of each order. Preactor 400 APS provides users with a complete picture of demand, capacity, resource usage, operation sequence, and expected start and finish times in the form of an interactive Gantt chart. The planner can interact with the chart by dragging and dropping operations in time and between resources that are capable of doing the work, and can also change priorities to see the impact on the overall schedule. Having used the automated rules and made manual adjustments and compared alternative schedule options, the planner can then release the schedule to the shop floor and to ERP. The planner also has a number of different ways to load orders: forward from the first operation, backward from the last operation, or bidirectional, where a critical operation must be loaded at a certain time and other operations sequenced around it. There are some built-in optimization rules available, such as minimize setups, theory of constraints, and other frequently used methods, but these rules are customizable to meet the requirements of the application. It also deals with multiple constraints. For example, you may require one of 3 machines, an operator with a specific skill set to set up the machine, and a tool to start. Or it could be that various tanks are used for storage before filling lines, each with a different capacity. Another feature available is the ability to take account of dependent orders. Often ERP systems generate a separate order for each level of the bill of materials for an order. These, along with bought-out materials, must be taken into account in the detailed scheduling process. Preactor has material control features to deal with this. Preactor will tell you when you can deliver orders based on all the constraints of the system. You can add shift pattern details and change these to add, for example, overtime working to see if this will overcome resource capacity problems. You can also save alternative schedules and compare them in a number of ways using tools embedded in Preactor. There are many proven benefits from using advanced planning and scheduling tools. Firstly, the tool allows planners to make faster decisions. Secondly, planners can be smarter. They can see the problems before they hurt and take action in advance to overcome them. It's like having a crystal ball for the shop floor. And the results, as proven by scores of users, are dramatic. A 90% improvement in on-time delivery performance, a 50% reduction in on-hand inventory and work in progress, and a 25% increase in efficiency and capacity available for the same resources. Some companies do not have a full ERP system. Preactor 400 GMPS can be integrated with Preactor 400 APS to provide both planning and scheduling without using ERP. This graphic shows what data is passed between APS and GMPS. For more information about Preactor, please contact us or visit our website www.preactor.com.